Hello everyone. Let's discuss the angle between two lines in this video. Okay, when they are given direction ratios, direction cosines, and when they are given the equation of the line. Okay, so we need to find, they will be given the two lines, and that lines they might have given in the form of direction ratios, or they may given the direction cosines, or they may given equation of that lines. Okay, we need to find out the angle between that two lines. Okay, how it is. Now let me take here two lines. P and Q are the two lines which is passing through the origin. May question arise? Will it pass other than the origin also? It may go, yes. The two lines may go other than origin also. Just now I am taking it as a when it passing through the origin. Okay. So let P and Q be the two lines which pass through the origin with the direction ratios. Please keep in your mind. I have taken here when they are in the direction ratios. Okay. With the direction ratios A1, B1, C1 and A2, B2, C2. Then what will be the angle between these two lines? Please keep in your dear students, there are two possibility of angles are there. One, it can be acute angle and one more angle will be there. Okay. Here I am going to find the acute angle between the two lines. Okay. So now first let me write that P and Q. Vector P is A1I plus B1J plus C1K and vector Q is A2I plus B2J plus C2K. So we know that the dot product of these both vectors is nothing but magnitude of P into magnitude of Q into cos theta. Magnitude of P into magnitude of Q into cos theta. So that cos theta is equal to, it comes P dot Q as it is, that magnitude of P into magnitude of Q. So we know the dot product of two vectors when it is in the component form. So here I need to do the dot product of these two vectors. Well, that both vectors are in the component form. So what's the component form? See, vector P dot vector Q. So when I do the dot product of these both, we'll be getting A1 A2 plus B1 B2 plus C1 C2 divided by magnitude of P is root of A1 square plus B1 square plus C square and root of A2 square plus B2 square plus C2 square. So this is my formula to find out the angle between two lines. Between two lines when they are given the direction ratios. Keep in your mind, when they are given direction ratio, this is my formula to find out the angle between two vectors, angle between two lines. So now, suppose instead of direction ratios, if they are given the direction cosines, instead of direction ratios, they are given the direction cosine, then what will be your angle between the two lines? Let us move. See, we know that vector, the given vector can be written when they are given the direction cosines in this form. Let me take the magnitude of first vector is R1. So R1 into L1I plus M1J plus N1K. Correct? It's the vector B in terms of direction cosines. Now, similarly, vector Q, the second vector. I am written it in the form of R2 into L2I plus M2J plus M2K. Now, let me find out the dot product of these both. So when I do the dot product of these both, same procedure, when I do the dot product of these both, this vector dot into this vector, correct? Dot product of these both divided by magnitude of this one and magnitude of this vector. So now let me cancel R1, R1, R2, R2. See here, dot product of these both vectors I am written here. In this vector, it is in terms of direction cosines, means L1I plus M1J plus N1K. There it was A1I plus A2J plus, A1I plus B1J plus C1K, correct? Here it is L1I plus M1J plus M1K. Okay, so I'm doing the dot product of these both now. So when I do the dot product of these both, I will be getting here just same as usual. Magnitude of L1 L2 plus M1 M2 plus N1 N2 divided by I have taken here divided by 1 1 because we know that the L1 square plus M1 square plus N1 square is equal to, L square plus M square plus N square is equal to 1, which you are studying in the previous chapter, correct? So L1 square plus M1 square plus N square is nothing but 1. Similarly, L2 square, again this is also the same thing. Sum of the square of the direction cosines of that will be equal to 1. Therefore, finally I will be getting P dot Q is equal to magnitude of this one. Okay, now I need to find the angle. So angle cos theta is equal to, what are we getting here? Magnitude of cos theta is equal to, as P dot Q is equal to what I have got here, because magnitude of L1 square plus M1 square and N1 square, that's value is nothing but equal to 1. So I dot P dot Q is equal to this value, then that's nothing but equal to cos theta, because cos theta is P dot Q divided by magnitude of P into magnitude of Q. So the magnitude of both the vectors is equal to 1. So I can write cos theta is equal to magnitude of L1 into L2 plus M1 into M2 plus M1 into N2. Okay, because magnitude of that both will not be equal to 1. Just when it cancels both the R value, the magnitude of P will be R into root of this one. Okay, magnitude of Q will be R2 into this one. Okay, these both got cancelled. So I have taken these both values as 1 and 1 because which we already discussed. Okay. These students here, these are all the things what we have discussed, the angle between two lines, two vectors. Okay, when it passing through the origin. Yes, when it is passing through the origin. Suppose if it is not passing through the origin. I mean, imagine that if it is passing through one line is here, one line is here, another one line is here. Then what will be the angle between these both? I mean, it's intersecting somewhere. Okay, imagine it's intersecting somewhere. Okay, then I need to find the angle between these two lines. How? Because this is a formula what we know when it passes through the origin. This we know how to find out the angle between two vectors. Okay. So when these both the given vectors are when it's not passing through the origin, please keep in your mind just to draw a line or draw a vector which is parallel to this one. Parallel to this vector. What the heck? Okay, parallel to this one and passing through the origin means, see, the parallel to this one and passing through origin, I can draw like this vector. Correct? Similarly, I need to draw one more vector or one more line which is parallel to this one, which is parallel to this one and passing through the origin. This way I can go. So then you will be getting the angle between these two lines when it passes through the origin. So the angle between these two lines will be same as the angle between these two vectors. Even though if it is not passing through the origin, you will be able to find the angle between the two given vectors. Okay. So now we have discussed angle between two lines when the direction ratios are given and when the direction cosines are given. Okay, so now when they have given the equations, what is the angle between two lines when they are given the equation of that lines? So as we know already, equation of a line, the vector form is nothing but r is equal to vector a plus lambda into vector b, correct? Yes. Now let me take the equation of this line, vector p is vector r is equal to a1 plus lambda into b1. This is a point vector. This is a parallel vector. Okay, B1 is a, we have discussed in the previous video, equation of the two lines, equation of a lines. Equation of a line when it is passing through a point and parallel to vector, and equation of a line when it is passing through 2 points. These both the theorems we have discussed, which is very, very important, correct? So in that theorem only we will be getting this equation of a line when it is passing through a point and parallel to a given vector, correct? So now I am taking vector P as this was the equation and vector Q as A2 plus mu into B2. Then what will be the equation? What is the angle between these two lines when they are given in this form? So please keep in mind, as already we know. Here, keep in mind, they will be given the B1 and B2, two vectors. Means these both are the vectors. See, we are not getting directly the angle. This is the point, and this is my vector line. Yeah, correct. So I need to find out like this. They will be giving two lines. Okay, I need to find out the angle between these two lines. But I can't find out the angle between these two lines because that first I need to find out here the line which is parallel to this line L. Similarly, there will be one more line. The parallel to that will be one more B2 will be there somewhere. Correct. So I need to find out the angle between B1 and B2. I mean, they will be given equation of a line when it is passing through a point and parallel to one vector, correct? So if you find out the angle between these two vectors, the vectors which are parallel to the given line, okay? If you find out the angle between these two vectors, you will be getting the angle which we need. So that means when they are given the equation of the two lines, I mean vector r is equal to a1 plus lambda b1, vector r is equal to a2 plus mu into b2, then the cos theta is equal to, please keep in mind, I need to find out the angle between B1 and B2, which is parallel to that line, correct? So B1 and B2, that is dot product of B1 B2 divided by magnitude of B1 B2. If you do this, you will be getting the angle between two lines when you are given the equation of two lines. I hope it is clear. Yes. Now let's move to the condition for perpendicular as well as the parallel for the given two vectors. I mean, when that two given vectors will be the perpendicular to each other, or when that two given vectors will be the parallel to each other. What is the condition with respect to angle? Okay. Suppose if the given two vectors P and Q, are perpendicular to each other, when the given two vectors are perpendicular to each other, we know already. So when the two given vectors are perpendicular, its dot product will be equal to 0. Correct? Its dot product is equal to 0. So which implies when it is in the component form. So just do the dot product, you will be getting this one. I mean, when the two given vectors are perpendicular to each other, please keep in mind a1, a2 plus b1, b2 plus c1, c2 is equal to 0. So now let's move to the next one. What's that? So if it is parallel to each other, I mean, given two vectors are parallel to each other. Okay. So when the given two vectors are parallel to each other, yes, already we know. When the given two vectors are parallel to each other, we can write in the form of vector p is equal to lambda into q. Vector p is equal to lambda into q. Whereas lambda is some scalar, one scalar value. Okay. Then, as we know already, the corresponding elements will be proportional to each other. Correct? So whenever the two given vectors are parallel to each other, then it has to satisfy a1 by a2 that should be equal to b1 by b2 that should be equal to c1 by c2. This is the condition for the parallel of two vectors. Okay. So now let's move to the next one of the important concept. Wrote all are important concepts only. So this one, because from this there will be one theorem for the finals. Okay. Skew lines. So before I go to the skew lines, dear students, let me make it clear. A board is a plane. It's a plane. If I draw a line like this, if I continue these both the lines the same way, do you think that these both will be intersect each other? Not chance. These two lines will never be intersect each other. That means these two lines are parallel to each other. So there is one more chance. If I extend these two lines, yes, it will meet each other. I mean, when you draw two lines in a plane, okay, in two dimension. I'm talking about now two dimension. Okay, when you draw two lines in two dimension, there are two possibilities. Either they have to parallel to each other, I mean, which never meet each other, alright, or they have to intersect each other. I mean, somewhere that has to intersect, means which never be parallel to each other. Okay, but in 3D, when you talk about 3D, there is a possibility of two lines can be drawn which never be parallel as well as which never be intersect each other. You can draw in a space. I mean, in 3D, you can draw which never intersect each other, as well as which never parallel to each other. So that kind of lines we call it as a skew lines. Please keep in mind, skew lines are nothing but lines neither intersect and nor parallel. They will not intersect also, they will not intersect also, they will not parallel also. That means, so imagine it's a plane, xy plane, or sorry, it's a xy plane. If it's a yz plane, here one line I can draw, there one line I can draw, which never meet each other, as well as which never parallel to each other also. This is one line I can draw here, and here one more line I can draw here. In this xy plane, I can draw one line here. In this xy plane, I can draw one line here. Correct? So it is the same thing. Here also, if I draw here, and in this way, if I draw, which never. Please not in plane. It is in 3D. I mean, in this plane, one line, and in this plane, one line I am drawing. Okay, so these two lines will never meet each other, and these both are not parallel also. So that we call it as a skew lines. So now let's move to the distance between, I mean the shortest distance between two skew lines. That's an important term for the 5 marks. Okay. Yes, dear students, now let's find out the distance between, shortest distance between the skew lines. Shortest distance between the skew lines. So again I'm telling, imagine this is one line and this is another line. So now these two lines, see these two here, these two lines which never intersect, which is not intersecting as well as not parallel also. See, this is one line and this is another line. These two lines are not parallel as well as not intersecting. That means these two lines you can call it as a skew lines. Now I need to find out the distance in that shortest distance between. Yes, shortest distance is nothing but it will be perpendicular to both vectors, correct? So I mean, I want to find out the shortest between these two both means I need to take perpendicular to both vectors, correct? That's the way I need to find out. Now let me find out the distance between your two skew lines. Okay, so then let me take two lines, L1 and L2 with the two vectors, which is passing through the point A1 and A2. See, L1 is passing through A1 and L2 is passing through A2, whereas L1 is parallel to vector B1 and L2 is parallel to, imagine, vector B2. Because in the equation of a line when it is passing through a point and parallel to a given vector, we have discussed that. Okay, so L1 and L2 will be the two vectors which are passing through A1 in A2 and parallel to vector B1 and vector B2 respectively. Okay. So now I need to find out the distance between, I mean the shortest distance between L1 as well as L2. So if it is the shortest distance between L1 and L2 means, let me take the 2 points P and Q on the L1 and L2. Okay. So the shortest distance between L1 and L2 is nothing but, it is nothing but PQ. Correct? It's nothing but PQ means which is perpendicular to both L1 and L2, which is perpendicular to both L1 and L2. Please keep in mind, I want to find out the shortest distance, so definitely that will be perpendicular to L1 as well as L2. Okay, so now here let the equation of L1 be vector A1 plus lambda into B1, and equation of L2 be the vector A2 plus mu into B2, which is passing through A1 and parallel to B1, and here this is passing through A2 and parallel to B2. So now let PQ be the, this PQ is the shortest distance between L1 and L2. Let me take it as D. Okay, PQ is the shortest distance between L1 and L2. So now, dear students, we know PQ is perpendicular to L1 as well as L2. Correct? So now PQ is perpendicular to L1 as well as L2 means definitely that will be perpendicular to even B1 and B2 also. PQ will be perpendicular to B1 as well as B2 also. So PQ is perpendicular to both B1 and B2 also. Now we know a vector which is perpendicular to given two vectors, or if I imagine this is a one vector A and this is one vector B. Now I want a vector which is perpendicular to this both. Now I want a new vector which is perpendicular to this both, which is nothing but A cross B. Correct? So this is a new vector which will be perpendicular to both vectors. The same way, now PQ is, already I have taken PQ is perpendicular to L1 as well as L2. I mean PQ is perpendicular to B1 as well as B2. So now PQ is perpendicular to B1 and B2 means then definitely vector PQ should be equal to cross product of B1 and B2. Correct? When you do the cross product of B1 and B2, you will be getting a new vector that only perpendicular to both the vectors B1 and B2. That means PQ will be getting PQ. Next, we know that here PQ, the distance between L1 and L2, PQ is the projection of AB. I mean impact of AB on PQ. Projection of AB, the impact of AB on PQ. Let me take A and B be the 2 points on L1 and L2. Okay. So next one, the projection of AB on PQ, vector PQ is nothing but PQ. PQ is nothing but projection of vector AB on vector PQ. So now projection of vector, any vector on another vector is nothing but dot product of that both vector divided by projection of AB on PQ means divided by magnitude of PQ. So now vector PQ is nothing but B1 cross B2 divided by magnitude of PQ is nothing but B1 cross B2. Okay, so now PQ is nothing but D. So I got here, please keep in mind I have taken here mode because distance will be always positive. Therefore, the distance between two given lines, two given skew lines will be always equal to AB. AB is nothing but terminal point minus initial point. So AB here, point AB is nothing but terminal point means A2 minus A1. So I have taken AB as A2 minus A1 and PQ is replaced, magnitude of PQ is also replaced. So finally my distance is equal to magnitude of A2 minus A1 into B1 cross B2 divided by magnitude of B1 cross B2. This is the my distance between two given skew lines. Again I'm telling you, please keep in mind, it's one of the important theorem which asks for the 5 marks. This will be asked for the 5 marks. Okay, so distance between two skew lines will be equal to A2 minus A1 dot B1 cross B2 divided by magnitude of B1 cross B2. It will be always positive.